The challenge being addressed within this project was outlined by an individual with limited mobility who had a passion for cooking. A request for an assistive device that would enable an individual to, while seated and utilizing only one hand, cut, chop, and prepare various food items without assistance was presented. In an effort to meet the client's needs, the chopping block was created by Team H to provide an appropriate method of cutting, chopping, and slicing various food items with regards to the restrictions presented. The chopping block, which consists of 2 washable bamboo surfaces, contains a variety of features which help to better enable the individual using it. These features include a wide cutting space fitted with a grid of stainless steel spikes, magnet-aided grip to keep the 2 boards together in storage, silicone grip below each board's corner to prevent slip, and an easily accessible grading system with easily replaceable grading surfaces. To start, the silicone grip located below each corner of both cutting boards provides an extra stability required by an individual using only one hand. This feature prevents the boards from slipping on any table or counter space, which alleviates safety concerns during the chopping of various food items. Second, the magnet-aided grip is designed to keep the 2 boards together when not in use. When designing the board, there was an incentive to create a device that could function both when deconstructed and together. The magnets provide additional resistance to slipping when using the top board over the other. A grid of 15 stainless steel spikes is located on the smallest board. These spikes allow for the user to stabilize food items that would normally require an additional hand for support. When in use, the spikes hold a food item in place, and the grid patterns allow for the chef to chop, slice, or cut in the horizontal and vertical direction. And finally, the built-in grater comes with a set of 4 different grading surfaces that will enable the client to grate food items in whichever way they please. The grater comes with a dish that holds and grated food, which helps to keep it in place, thus preventing a mess. We started this process by coming together with any ideas we could imagine that might be a solution for our given problem. We discussed ideas ranging from an automated knife made out of a branch trimmer to a device that could mold into any desired shape in order to hold foods. After many hours of discussion, we decided the most appropriate solution would be a multifunctional, stackable cutting board. We then had to begin the drawing phase. As our ideas began to take shape, we began to form a mental picture of what the end result could look like. The next step would be to take our 2D drawings and transform them into a demonstrative 3D model. We then created this model out of cardboard and colorful paper. It gave a sense of position and scale. It was in this stage that we began to edit our ideas and decipher which aspects would be possible to construct with our time limits and budget. Ideas such as 3D printing were discussed and ruled out because it did not meet the requirement of being food safe. We then moved on to our first prototype. This phase entailed an exploration of food-grade materials and construction methods. We decided high-density polyethylene would be too hard to work with and not appealing enough visually. This was discovered with our first prototype, which was made of high-density polyethylene. We also decided to boycott the 3rd layer altogether, as it was adding unnecessary weight with not enough practical payoff. Losing the 3rd layer left us with a more stable and sleek design. Other aspects of the design that we decided to omit were a control surface and serrated wall around part of the cutting board to hold food. Both the ideas were great in theory, but in practice they were not useful. Therefore, we left them out of our final design. We also originally were planning to curve the outer edges of each layer, which would allow for the layers to stack, but this feature would be much too difficult to manufacture with the tools we had available. So the magnet solution was used instead. After this first prototype, we learned many lessons and were ready to begin the final construction. Final construction of the cutting board began. We decided to work with a pre-made bamboo cutting board, which was much lighter and more visually appealing than the high-density polyethylene. We also bought a grading device. It was so well designed, we decided to use it as is instead of using the inserts on a whole new cutting board layer. After several hours in the workshop, we had finally created a device we were pleased with.